discuss about the project which we have done, bike sharing demand prediction. In this model, we can predict the increase in the demand of the bike sharing when depends on the day and season and weathers. Bike sharing is an increasingly properly part of a urban transportation system. So, which means that so many people in the urban area are going to use this system. So, by this model, we can get the accurate demand of the bike sharing, and so that we can forecast the future. So, in this model, we have used the light gradient booster machine this for predicting this project. As this model is giving the best output for our model. So here we are going to discuss about the few details in this PPT. So these are the first we are going to start with the bike sharing system and the prediction problems, and later on continuing with the for whom this model is useful, and data overview and exploratory data analysis. So what are the factors affecting the bike sharing systems, and we gonna graph the some of the plot the graphs, and there we can see the heat map of the on which factors the bike sharing is mostly depends on. And also we are going to discuss about the models which we are used, and the precise model which we are selected and given the best output for our model. So bike sharing system is a places where individuals may rent a bikes from the bike racks or the dogs like that, and most of the commuters are for used for the daily office commuters and tourists for short distance travelers. Recently, several bikes and scooter riding businesses has emerged, particularly in major cities like the San Francisco, New York, Chicago, and Los Angeles. So, from a particular point of the view, one of the biggest challenges is predicting the demand for the bikes on a particular day and a particular season, and depends upon the weather and temperature. Having an estimate of demand would help the businesses to operate efficiently, which will have too many bikes results in resource waste. Having too few bikes results in income loss. So to cover up this entire income loss and resource waste, we are predicting this model.
So on the top, you can see like what are the libraries which we want to import to start this project. So in the first one, you see we imported all the libraries which we want to use it for it. On the second line, you can see like we have two types of data. One is used to train the data, and the other one is to test the model. So we have imported both the files. And the next one comes, we just want to uh, test the sample data which we have imported from the CSV files. So I have just like took five columns of data just to just see them. Going down, train data.info gives us the basic structure of the datagram of pandas which we have imported, so that we can be able to understand like what are the types and what are the columns which are available there. Same for the data test data as well. And describe is a function that states what is the mean values, standard deviation, minimum, and what are the values that are used that are in the particular fields which we included. So that gives us a overview of data which we are importing into the files. Next, we need to pre-process the data before using it for analyzing. So first of all, I have removed all, I have dropped all the duplicates from the trained data which we have imported from the CSV file. Next, to understand the distribution of data which we have imported, I used a box plot that shows the variation, like where is the most of the numerical data is present in the values. And when going down, so this is a scatter plot between four parameters that are called as temperature, air temperature, humidity, and wind speed. That shows us where is the deviation in the values, and which values are not deviated much. So that we can understand here in the humidity we can see a little bit deviation as anomalies, and here as well you can see a little bit deviations are able to see. And next, I have drawn a box plot for the same for the parameters of season, holiday, weather, and working days, to understand where they are lying, and where are the anomalies that are going for from the data. And you can see the results with four different types of box plots. And this is the line plot that states how the values are going in a different format. On the top I used a box plot, and here I am using a line plus as a different way of seeing the data. coming to this is a heat map with all the parameters which we have included, so that this particular heat map says which are the weights that are mostly involved in the giving the accuracy of the particular count which we are predicting this model. Coming next, in this particular point, when we got the data, the object the type of the date and time is like kind of object. So to convert it into date time, I'm just importing it into date time, and I'm just checking the samples of the data and kind of structure for it. Then as we want to remove particular fields which are not required for pre-processing, I need kind of year, month, day, week and kind of fields. So I just am splitting the date time into these particular fields, and just validating is it coming as correct. As you can see here, we have years, month, day, hours. And I dropped date time because I don't need that particular column after this. And I have also dropped casual and register, as these actually which we want to predict by removing these two particular fields using our model. And I have done the same thing for the test data as well, to divide the date and time, and I have dropped the date and time particular column from the table. And I have just validated to just see did they reflect it in particularly in the train data.info. Coming next, I have defined 3 subplots that will show as a bar plot, so to understand the kind of bike usage between the year, month and hour comparison. As you can see, in the 2011 it was little low and it was higher in the 2012. When coming to months, as you can see on the 6th and 7th month, you have seen like a constant increase here, and when you see in the first month, it's like a little bit low, less usage in the first months. When you see, this is a hourly time frame where you can see there is a huge spike in the morning hours and at the 17 and 18 hours, and the other hours when you see in the morning it's very low of usage. This is a box plot where it shows I have compared with the working day and non-working as a parameter, stating that when on a working day how the particular bikes are used at a particular point of time in the day, and on a working day and a non-working day. So it shows a graph stating that at particularly on a working day or the morning there are huge usage of bikes, and in the evening, and on a non-working day like it comes to 10, it's a slight increase in the usage of bike, and it's keep on using it. When coming to this is the same bikes distribution on the particular, but when coming to the above graph, it was for a 23 for a day. When it's come to this, it's a comparison between months. So gradually from start it's a little low, when going up the month of 6th and 7th it's huge in the June and July months. And coming to this plot, this plot, it's as you see a huge deviation in the data, so we want to little bit sequence this. So I used the log 1p function so that the data is equally shared, and then I just checked it with the box plot. As you can see, there is no deviation, just little bit anomaly of data is present. And here I have drawn a scatter plot to understand how the data is equilibriumly stated. And then going below, so from the scikit-learn model I have divided the data into four pairs, like X-train, X-test, Y-train and Y-test. Using these four fields, I used 7 different regressor models. I'll show it in the below bottom. So these are the 7 models which I have used to train the data and to test the data. After analyzing the data with this particular evaluate function for all the 7 regressors, as you can see, the most accurate model which I see the results are coming is LGBM regressor, which comes with 96.33 than the other models. So I choose LGBM regressor as the final one for my prediction model. And you can see the future importance of this, as these are the fields that are mostly involved, like what are the parameters that are more involved in it. And we took a sample CSV file for the particular dates to get the results into a CSV file. And finally I pushed all the data into output.csv file that shows like when the date when the count of the bikes needs to be set.